On this video, I'm going to work through the number value problems that were on the handout that you received in class. Now, before we jump into the first one, the reason they're called number value problems is because the let statements will have to do with the number of items that you have, whether it's coins or stamps or tickets or whatever. The value of those will be what we use to come up with our equation. So, let's look at the first one. Okay, here's our first problem. Chris has 17 coins and they are all dimes and quarters. If he has a total of $2.45, how many of each coin does he have? Alright, so I need to use the information about the number of coins for my let statement. So here's my step 2. I can choose either the dimes or the quarters. I'm going to use the letter D. Let D equal the number of dimes. If I have 17 coins altogether, then 17 take away or subtract the number of dimes would end up giving me the number of quarters. Anytime you have two quantities that add to a number like 17, you use x and 17 minus x, or in this case d and 17 minus d. Alright, so our let statements had to do with the number of coins. Our equation must have to do with the value of coins. Now if I take the number of dimes times 10 cents and add that to 25 cents times the number of quarters, I get $2.45. Now I can't write 2.45 because I've got my coin values written in cents. So I need to write 245 cents. And the reason is this is in cents, this is in cents, this must also be in cents. Okay, now let's work that out. Okay, I've worked this out and I have D equals 12. Now it's a good thing that D came out to be an integer because it stands for the number of coins. Alright, now if D is 12, we need to find the number of quarters. The number of quarters is 17 minus D, or 17 minus 12, that must be 5. So circle that, come over here and put your step 4, and then write step 5. Therefore, there are 12 dimes and 5 quarters. Now run a check with that and make sure that that makes sense. 5 quarters is $1.25, 12 dimes is $1.20, they add to $2.45. Now I just want to point out again before we move on that the let statements here have to do with the number of items I have, the number of coins. The equation here has to do with the value of whatever objects I have. That's why they're called number value problems. Okay, look at this problem. Jim has a jar of dimes, nickels, and pennies. He has 1 dime more than 5 times the number of nickels and 4 times as many pennies as nickels. If he has $7.77, how many of each coin does he have? Alright, so we're looking at finding the number of dimes, nickels, and pennies. For my let statements, remember that we're going to write our let statements based on the number of coins that I have. I'm looking at dimes, nickels, and pennies. Now when I look at the information here, I've got 1 dime more than 5 times the number of nickels, and I have 4 times as many pennies as nickels. Notice that it doesn't tell me anything about nickels. That means we should probably start with letting We'll just use n. Let n equal the number of nickels. Alright, for the dimes, to represent the number of dimes, I have one more than 5 times the number of nickels. So here's 5 times the number of nickels, and here's one more. Okay, now I also need the number of pennies. The number of pennies is I have 4 times as many pennies as nickels. So if I knew the nickels, I would just multiply by 4 to find the number of pennies. Okay, now that has to do with the number of the coins that I have. Okay, now we're going to look at number 3, which has to do with the value. Alright, a dime is worth 10 cents, a nickel is worth 5 cents, and a penny is worth 1 cent. So I'm going to take 5 times the number of nickels plus 10 cents times the number of dimes plus 1 cent times the number of pennies. Now I get $7.77, but I need to write that all in cents, $7.77. I'm going to solve this by doing my distributive, collecting like terms, and continuing. Alright, I've solved this equation, and I got n equals 13. That means I have 13 nickels. Now, I'm just going to do this over here because I'm running out of space. I have 5n, or 5 times 13, plus 1 dimes. So 5 times 13 plus 1 would be 66. And then 4 times 13 would be 52. So these are also part of my step 4 over here. So step 5, and it's a good thing these numbers all came out as nice integers, therefore there are 13 nickels, 66 dimes, and 52 pennies. Alright, here's our next problem. Game tickets cost $3 for adults, $2.50 for kids. If Sam bought 2 more adult tickets than kid tickets, and he spent a total of $61, how many of each type did he buy? Alright, so remember, our let statements have to do with the number of tickets. Now, I've got kid tickets and adult tickets. I don't know anything about the number of kid tickets, so I'm going to let x equal the number of kid tickets. That means I also need to show the number of adult tickets. The number of adult tickets, you can see there are 2 more adult tickets than kid tickets. So that means there's 2 more, or x plus 2, adult tickets. Alright, again, that has to do with the number of tickets. And for step 3, our equation has to do with the value. Okay, let's look up here and see what the value is. It's $3 for adults, $2 for kids, with a total of $61 spent. So, just like with the coin problems, if I take $3, and because we have $2.50, well, let's go ahead and do this, and then we'll clear the decimals. So let's say I've got $3 times the number of adult tickets, that's x plus 2, plus 250 times the number of kid tickets, that's x, and that's a total of $61. Now notice what I have here. I've got decimal numbers showing up, so what I would probably do right away is I would multiply all the way through by 100. I would multiply this by 100, this by 100, and this by 100. And what that accomplishes is it moves my decimal point over 2 places here, 2 places here, and 2 places here. So my new equation ends up being 300 times x plus 2 plus 250 times x equals 6100. Now, if you look at that, that's the same thing we would have gotten if we had just written everything in cents to begin with. So my advice to you would be, if you have a problem that has an amount that is a decimal amount in dollars, change everything to cents. Okay, so I'm going to go ahead and solve this. Alright, I've got the equation solved and I got x equals 10. So that would be representing the kids' tickets. The adults' tickets are x plus 2, so x plus 2 would be 12. So I go over here, put my number 4, and then number 5, therefore, he bought 10 kid tickets and 12 adult tickets. Okay, to review number value problems, the let statements should deal with the number of items. The equation should deal with the value of items. Note that you should always change the dollar amounts into cents to get rid of the decimals, and for coin problems, use cents for values instead of dollars. Good luck.